This is the objective, to measure the angle of a V groove by using optical bevel protractor. Here I have to correct the title. It is the old title. Now I have revised it to just to measure the angle of V groove by using an optical bevel protractor. So what are the apparatus which are required? These are mainly optical bevel protractor, which has the capability to measure the angle from 0 to 360 degree. Then we require a surface plate of this much dimension, 450 by 450 and work holding devices to suit a particular job, and it is optional. So that depends upon the size of the job to test or the complexity of its shape. These work holding devices are optional and it depends upon the skill of the operator. These are the equipments which you use in this experiment. This is our optical protractor and this is our surface plate, which is made up of either cast iron or granite. These are some of the examples of work holding devices. These are standard machine table devices which you might have seen in the fitting shop, that these are two jaws of this vise, and then you can clamp your workpiece in this particular gap. And there is some slight modification in this particular vise, that it has some rotary table, which is swivel type of vise. And sometimes you need to measure the object which is having some angular orientation. For holding that particular object, you need some this special vise which is an angular vise. These are optional devices. Work holding devices are optional, but you would be requiring the optical protractor and surface plate. Then in the theory, you all know that what is a protractor. Protractor is an instrument or a device which is used to measure the angle of a surface or any object. In your school level, you might have used, you know that how to use a protractor. That simple protractor might have seen, it is having a shape of D. Sometimes we call it a protractor, and it measures the angle from 0 to 180 degree, and the smallest measurement taken can be taken in degrees only. In this case, we have a special type of protractor which is called as bevel protractor. You can see it has a circular scale. This is our main scale of this particular instrument, and it is having the angle from 0 to 360 degree, but it is divided into 4 different parts: 0 to 90, then 90 to 0, then again 0 to 90, and similarly you complete the circle, you complete the 360 degree angle in a circle. And then this is the main body. There is a base plate called as a stock attached to the main body. There is a blade which is used to measure the angle of a surface. This whole instrument is made of high carbon, high chromium stainless steel. You know that what is the use of that particular material. This is particularly used for high wear resistance and corrosion resistance. So this is a circular scale. At the center, there is a swivel type of rotary scale, to which there is another scale called vernier scale. And this blade is, you can say, it is having a length of 150 to 300 and thickness is about 2 The length of this particular base plate is about 90 and its thickness is 7 And this blade is attached with an arm, and it is having a groove. As you can see from this figure, this is your blade which is having a groove in the middle, and this groove can slide under this particular nut. So that nut allows the movement of this blade up and down at any particular length, and at any particular distance you can set the distance with the help of this locking nut. This blade is having beveled edges. This particular edge is having 45 degree angle, and opposite this end is having a 60 degree angle. So we have two types of scales in this particular instrument. One is the main scale, which is having angles from 0 to 90 degree, then 90 degree to 0, 0, 90, like that. You complete a circle. Then there is a small scale, which is a vernier scale, and it works on the principle of vernier, as we have already learned how a vernier scale works. So same type of principle is used in this particular instrument. This is a mechanical type of bevel protractor. what is the limitation of a mechanical bevel protector, that it is very difficult to read the angle properly. So in order to resolve this problem, this particular section is having small eyepiece or a magnifying lens, so that the readings are magnified and it is easy for an operator to read out the angles and take the measurement carefully. The next figure is of optical bevel protector. In this case, you can see a magnifying lens placed over your vernier scale. So whatever the angle you measure, it is magnified and you can take the readings carefully without inducing any error. This particular edge is placed on a flat surface, and if you want to measure any angle, you incline this blade along that particular surface which is having an angle. Due to the movement of this blade, you will have a movement in this vernier scale, and the zero of the vernier scale will give you the angle which is being made between these two edges. One is the working of edge of this base plate, and other is the working edge of the blade. This is brief description about this particular equipment. And now we come to that how we will study or we will read the angle or take measurement. First of all, you know that for any equipment, it is very important to find out the least count, so that it will give you an idea that how much the least measurement that you can perform with the help of that instrument. In this particular instrument, you have two types of scale. This upper scale is your fixed scale, which is your main scale, and this scale is your vernier scale, which is a movable scale. With the movement of your blade, this scale moves and then aligns itself to a particular angle which is present on the main scale. Fixed scale is divided into degrees, and one single division equals 1 degree, whereas the lower or small scale is of vernier scale, and it has 12 divisions from 0 to 60, and each division is having 5 minutes, and therefore the 12 division makes 60 minutes. What is the minimum value of a single division of a vernier scale? It is the 5 minute, and the total divisions are 12 in number, so that makes 60 minutes, and 60 minutes on both the sides, from the right hand side and on the left hand side. And these 12 divisions on vernier scale are equal to 23 divisions on the main scale or your fixed scale. If you want to calculate the value of one vernier scale division, it will equal 23 divided by 12 degrees. 23 divisions on the main scales are equal to 12 divisions on the vernier scale. This is the construction of this equipment. From here you can calculate the value of one vernier scale division, which comes out to be 1 degree and 55 minutes. Here in this diagram you can also see that one division on the vernier scale is equal to 1 degree and 55 minutes. If you compare the 0 from 0 to 60, it will have 23 degree on the main scale. If you match the 0 of vernier scale with the 0 of the main scale, then you will observe that one main scale division means that 2 degrees on the main scale division will matches with the one vernier scale division. Means if you see in this particular figure, if you see here, this is the one division, and if this 0 is aligned to the 50 degree, then you will observe that one division will match with the 2 degree on the main scale. From here we can have the least count that works on the principle of difference in the scales. So the one main scale division, how much is the value? Here the one main scale division was giving you 2 degrees. When you were matching both scales, you observe that you are getting 2 degrees with the one scale division. So 2 degree minus what is the value of one vernier scale division? It is 1 degree 55 minutes, and by the difference you will get the least count to be 5 minutes. So the least count of this equipment is your 5 minutes. And now the vernier scale is having the divisions on both the sides, same divisions on both the sides, on left hand side and on the right. So the question arises, which side you have to consider. This can easily be judged with the main scale measurement. You have to see that you consider the case here and see what is the angle formed on the main scale. To start with the 0 of the vernier scale and then see where it is matching. So from here you see that this is 50 degree. So that means the zero is starting from here. That means you are moving from this side to this side. You will consider this left hand side scale. If your zero on the main scale is starting from this side, you are moving in the clockwise direction, then you will consider this right hand side scale. Here in this particular case, your zero is somewhere here and you are moving in the anti-clockwise direction. That means you have to consider this left hand side scale on the vernier scale. If you see here, what will be the reading here? 50 is the full value, and after that it is 51. After 51 it is coming in between 51 and 52, and then you see that which particular division on the vernier scale is matching with the division on the main scale. Here you see that this particular 45-minute division is matching with the 60 degree. You will consider the value of vernier scale to be 45, and then what will be your reading? It will be 51 degree and 45 minutes. So it is directly the 45 minutes. And similarly here in this case, you tell me what is the angular measurement here in this case. So first start with the zero and see where it is. So it is 20, and then it is 25, then 26, and 25, 26, then 27, and then 28, and total will be 28, and you are moving from this to this direction. So that means you will consider this particular side of vernier scale, and you see here which division is matching with the main scale. This is the 15 minutes. So what will be the reading here? 28, 28 degree and 15 minutes. In this way, you can easily calculate the measurement with the help of this bevel protector. Certain measurements, this is the V group. Suppose if you want to carry out the measurement or you want to calculate the angle of this V group, first you will rest your base plate or your stock over this flat surface. Then you move your blade like this, and then you inclined it over this surface to measure. Then you can have a reading on the magnifying glass. So this is the way. And similarly here also this type of arrangement. Then if you want to measure the angle between these two surfaces, you rest your stock or your base plate on this particular surface, and then you align your blade over this particular surface. In this case also you can measure the angle. These types of measurement you can perform. I will show you one video on YouTube. This video you must see. We see about the box one function of bevel protractor. This is the 3D model of bevel protractor. The main parts of bevel protractor: main scale, vernier scale, blade, base. The scale can be designed consistent. So you see here that we have this main scale, and then at the center there is a central disc to which the vernier scale is attached, and onto this there is a magnifying glass, and through this glass you can easily see the reading. You see here that currently the zero is matching with the zero. That means both the blade and your base are parallel and opposite to each other. So there is no angle and it's zero angle. Is degrees, reading from 0 to 90 degrees So you tell me what is the angle, current angle now from this particular figure, if you are able to see the angle. and which division is matching, and you tell me which side to consider for the vernier scale. What is the main angle? Yes, 60 degree. Now tell me what is the angle? Yes, 74 or 75. So that means you are able to measure the angle. Then you have the idea clear that how to measure the angle. And just you have to see from where the zero is starting. Okay. And in the same direction, you consider the vernier scale. So I think now you have the idea that how to place your bevel protector over the workpiece, and how to align the blade over the surface to measure. After this, you have to study what is the procedure. First, you study the bevel protector and identify its main parts. Then introduce the adjustable blade in the slot of the body and clamp it with the help of the knob in the convenient position. With the help of that knob present on the main body, you can adjust the length of the blade, and then you can place your working edge of the stock onto the surface of the job, of any flat surface on the job, and then you rotate the turret or align the blade over the edge or surface you want to measure the angle. You have to fix the turret with the help of the central locking nut. This is the locking nut you see centrally. This is the locking nut which locks the rotation of your bevel protector. This this you can say this locking nut is used to lock the length of this blade, and this locking nut is used to lock the rotary movement of your bevel protector. Then after this, you measure the angle. You have the main scale reading that you can check with the help of the zero scale. You can say division of the main scale is coinciding with the zero of the vernier scale, and then you decide the side of the vernier scale depending upon the direction of the measurement. Then with the help of your least count and the vernier scale division, you multiply it and get the total value in minutes to your main scale division reading. This is the procedure. These are simple precautions. Use the instrument with care and cleanliness while doing the measurement and any type of testing. Your workplace should be neat and clean. Your hands should be clean, and there should not be any dust or grease your hand as well as on your equipment, because it will introduce error in the reading. The main thing in this experiment is the capability of your eyes. So the eyes must be, can say, must be aligned or must be perpendicular to the magnifying lens. Your eyes should not be tilted, or your, you can say, your equipment should not, you should not be looking on from the sideways. So direct measurement, for the correct measurement, your eyes should be perpendicular to the magnifying glass, and always check the tightness of clamping screws. So what will happen if you don't tight it properly, then these loosened screw will cause any opening in the angle between both the stock, between the stock edge and the blade edge. When you have aligned your blade over the surface, then you should tighten all the clamping screw properly. The last precaution is very important. There should not be any visible gap or clearance between the job surface and working edges of the stock. So what does it means? That see here in this case, this edge is perfectly placed over this particular surface, and when you are looking over it, then there is no clearance or gap between these two surfaces. Similarly here, this blade edge should properly placed over this surface, and there should not be any gap, and then now only you will be able to measure the angle without error. So if you like the video, then please subscribe to my channel, share it with your friends, and don't forget to hit the bell icon for the latest updates. Thanks for watching my videos.